Alright, so now we're going to talk about the laws of sine and law of cosine when it comes to these two sections itself. I put them together because, they're basically the same thing, used the same type of ways. The only difference is, depending on how the triangle is given to you, it depends on you're going to be using the laws of sines or cosines. But these are the main concepts when you're going to be using the laws of sine and cosine respectively. Okay, so I'll give you a picture of which each one when it's respectively when it comes to it. So the first one says when one side and two sides are given to you. So a picture of when that's actually happened is, well, remember now this time is, what if you're not given a right triangle and you give an arbitrary triangle itself, right? That's the main concept of using laws of cosine and sine. So what number one says, if you're given one side and two sides or two angles, is, well, you can have a situation like this where you're given this angle and that angle and a side between them. That's when you can use the laws of sine or cosine. Another way you can do this is, vice versa. Suppose, you have this side, and let's say this angle here and that angle there. Okay. Now, again, right, all this is saying it's arbitrary as long as you're given one side and two angles. So this side can be over here, there, however you choose, and two random angles as well. So I try to give you, the best scenario when it comes to it. So that's what represents number one means. Number two means when it's two sides and one angle opposite of them. So this is very, very particular. So how number two will look like is kind of like a triangle looks like this, where you have, let's say, this side given to you and that side given to you and an angle out here, which is going to be the opposite of here. Okay, so something similar to that. Okay, and number three says if two sides and one angle between them are given. Now again, this is also very particular because it has to look something similar to this. Well, let's say this angle, you're given that angle there, so therefore this side and that side must also be given to you because it's the angle between the two sides. Now again, right, I can just swap these around, given that angle, these two sides, given this angle, those two sides, right? But the same concept applies. You're just going to rotate the entire triangle and make that true itself. And the last one, which is the easiest to understand, is three sides given to you. So basically, it's a triangle where all three side lengths are given to you, right? So those are the main concepts you want to talk about when it comes to using the laws of sines, law of cosines, is when you actually have these type of scenarios. Okay, and we're probably going to go through all of them just in case you guys can see how that would work about. Okay, so next page we actually have the laws of sine and cosine. Okay. So those are the laws we're going to help us out. So I'll give you guys a hint. Laws of sines is actually the easiest of the two. Trust me. Laws of cosine could be, pretty painful when it comes to it. But, we're still going to go through them and try those out as well. Okay? So here's laws of sine. So laws of sine says, so remember going back, right? So let me just give you an arbitrary triangle. So here, if you guys remember. So remember the angles between them are capital letters. And that means the sides are opposite are lowercase letters. So this is A, so this is side A here. This is C, so this is side little c, and this is B, right? Respectively. And this works for both these ones, okay? So what this says, the sine of capital A, the angle over the side A, is equal to sine of B, angle B over side B, is equal to sine of angle C over side C, right? So in other words, it's basically saying is the ratio is all the same. But that's where it comes to laws of sine. Okay? Now, laws of cosine applies when it comes to the sides themselves. It gets more in depth with the sides. It's kind of like Pythagorean's theorem in a sense without this extra stuff. You're actually subtracting the angle itself. So this says, respectively, c squared is equal to a squared plus b squared minus this chunk here. It's 2 times ab times cosine of capital C, and respectively goes down the list as well. Okay. So what we're going to do now is, let's try some examples out using these laws of sine and cosine respectively, right? So let's suppose this is our triangle here. Okay. So this is a triangle, right? So we're given one side and two angles there, right? Now the good thing is it tells us, right, we want to use laws of sine to help us out. So we're going to use the first ones when it comes to it. So the best we want to figure out is literally just label our triangle out first. So notice they give us C and B, so therefore this must have to equal A, right, when it comes to side A. Okay. So this is C already, so in that case, is this angle B or A? Well, it's the opposite of side B, so this must be capital B, and therefore this must be capital A respectively, right, when it comes to it. So what we want to do now is, using our laws of sine and cosine, is write down this formula using the angles or the numbers given to us, right? So in this case, we'll have sine of A, which is 40 degrees, over side A, which is 4, must equal sine of B, which is 60 degrees, over sine of B, and this is equal to sine C. Well, we don't know what C is, right? However, you guys remember what is the sum of all the angles in a triangle must be? They have to equal 180. So in other words, these three angles together must equal 180. So therefore, using a little bit of algebra, right? 180 is equal to 60 plus C. We could just solve for angle C very easily, right? So therefore, angle C must equal 80 degrees. Okay. So that means this is going to be sine of 80 all over little c. Now, let's see if I can just block one off here. Let's suppose we just block this off here. Hopefully it looks very familiar. It's the proportions equation, right? So if you have two fractions equaling, you can have proportions. So just in case you forgot the little note, here's a little note for it. So whenever you have two fractions equaling one another, let's say like this, A over B is equal to C over D, respectively. Why is this so blurry? Maybe a different color better. So if that works, therefore you can technically cross multiply, and you get AD is equal to CB. So that's the proportions equation, okay, when it comes to it. So that's what we're going to actually be using here. So we're literally just going to cross multiply. All right, so just using parts. So if I just push that over, we're going to cross multiply and cross cancel and then solve for B respectively there. So this is going to be B times sine of 40 is equal to 4 times sine of 60. Okay. And remember, we want to solve for B, right? Because we want the other one, so solve for the other sides. So we just divide by sine of 40. So side B is 4 times sine of 60 divided by sine of 40 degrees. Okay. Now, most of these you could probably find in the periodic table, or not periodic, the unit circle itself, right? So nothing like that. So let me show you how this would end up being. Some of these you may not be able to, but this one you actually can. So, for instance, what I mean by that is, if we go to our sheet over here, right? We can actually go at sine of 60 itself. But we have a problem. I have no idea what sine of 40, right? We know what 45 is, right? So this is what I mean by sometimes you can or can't. Some of your homework questions will give you precisely 30, 60, 90, 45, or portions. But sometimes they give you some obsolete ones, like sine of 85 or 33, which is it's impossible to see without a calculator do that. So for instance, when you have that one, it's not on the unit circle itself, like we have here, right? These are not on the unit circle, like 40 is not on the unit circle. You leave it just like that. That's what sine B is. So that's what side B is going to be, just like that. Okay. So you do not plug in the calculator. If you do plug in the calculator, you're probably going to get it wrong, and I'll talk it wrong. I want the actual algebra itself. You'll see that, and a lot of professors do the same thing. Okay. Which means we'll do the same thing on the other side, right? So same exact template, right? So if I just cross up the middle, we do the same thing. We're going to cross multiply to find what side C is going to be itself. Okay. So if we just cross multiply here, again, it's going to be C sine 40 degrees is equal to 4 times sine of 80 degrees. And then just divide, so side C is going to be 4 sine of 80 divided by sine 40 degrees, right? And there are two sides there, using laws of sine. Okay. So notice this is a lot of manipulation, just pure algebra, not too much when it comes to like trig itself, like unlike the other sections were. Okay.